Okay, section 9.3 is on probability. So what you're going to learn about is sample spaces, probability functions. We'll determine probabilities. We'll use Venn diagrams and tree diagrams to do it. And we'll talk about conditional probability, binomial distributions, and obviously everyone should know a little bit about probability. So this is our main formula for probability right here. It's the number of outcomes in basically this sample space that we're looking for, divided by the total number of outcomes in the entire sample space. So here's a common example then. If you were to roll 2 die, if the outcome was to get a 2, there's only one way you can do that out of the total sample space of 36 possible scenarios. You obviously have 6 times 6 because you have 6 possibilities for the first roll and 6 for the second die. So together, you'd have 36 total. So, if you wanted to roll a 3, there's 2 ways you can get a 3, a 2 and a 1, or a 1 and a 2. So the probability that you roll a 3 is 2 out of 36. If you look at the probability, for example, of a 7, there's a lot of different ways you could get a 7. A 1 and a 6, a 3 and a 4, 4 and a 3, 6 and a 1, a 5 and a 2, a 2 and a 5. So that probability is going to be the highest because there's the numerator of that fraction. There's the highest number of all of these. So here is an example then. Let's find the probability of rolling a sum divisible by 4 on a single roll of 2 fair dice. So how can we roll something divisible by 4? Well, that's a 4, that's an 8, or that's a 12. Those are options of numbers that are divisible by 4 with the 2 dice. So how many ways can we get a 4? Well, that information was up. And if you don't have it memorized, sometimes it's helpful just to write it out. So how many times can I get a 4? Well, a 3 and a 1 would do it. A 1 and a 3 would do it, and a 2 and a 2. Those are the ways I can get 4. So there's 3 options. How about an 8? An 8, I could roll a 2 and a 6, or a 6 and a 2. I could do a 3 and a 5, or a 5 and a 3, or also a 4 and a 4. And then how many ways can I get a 12? Oh, there's only one way. That's a 6 and a 6. So if you add up all the ways that you could get a number divisible by 4, there's 9 total, and we know the sample space is 36. That reduces to 1/4. So you have a 25% chance of rolling something that's divisible by 4. Okay, so the probability function, if we deal with this at all, we could assign a real number to each outcome in the sample space, and the probabilities total would add up to 1. Each probability of a single event would be between 0 and 1. They would all add up to 1. And the probability of nothing would be 0. So for example, with this example that we did right here, we could call this 1, this 2, this 3, and so on, like x, y almost, to make this, this would be our probability function then, where all of these add up to 1 because they're all the probabilities here. And now we've got real numbers assigned to each of these outputs. So here's an example then. Let's say we have a box of chocolates. We like vanilla the most, and 5 of them are vanilla out of the 12. What's the probability that we pick all vanilla? Well, if our first pick is going to be vanilla, the chances that we get vanilla is 5 out of 12. Then obviously, if we're going to pick another vanilla, there's only 4 left out of now 11 total. And the third pick, there's only 3 vanilla left out of the total 10. So that would give us the probability, which simplifies to, if you multiply it out and simplify, you get 1/22. The other way to do this is the total in the sample space. You're picking 3 from 12, so it'd be 12C3, and you're picking 3 of them from the 5 vanilla. So it's the total number of ways you can pick 3 vanilla from 5 divided by the total in the sample space. That should also give you 1/22. So we have 2 different ways to look at these problems. And what I just used in the first way that I solved that problem was what's called the multiplication principle of probability. And that's what the book says here. We can just multiply the individual probabilities together to get the total probability. Okay, the next is conditional probability. We'll just cover this hopefully in the homework. And I don't have an example for you now, but you'll find this in your formula sheet. It says that if an event B depends on A, so the probability of B given that A happens, is the probability of both the events happening divided by the probability of event A happening. So we will do examples of this later. All right, now next is binomial distribution. This is going to be a little confusing right here to read through this, but basically this comes right from the binomial probability theorem, or the binomial theorem that we learned about. Only now we can put our probability of success and probability of failure here for something that's binary, something that has either a success or failure type experiment. So let me give you an example. Shooting free throws is a perfect one because you can either make or miss, and we know the probability of success is 0.92 or 92%. Probability of failure would then be 8% or 0.08. And if we're going to make all 15 free throws, that'd be the first one. So we do 15C0 or 15C15, doesn't matter. Probability of success to the 15th power, probability of failure to the 0th power. So this is always just one. The first, term in Pascal's triangle. Probability of success then is 0.92 to the 15th. Probability of failure, it goes to 1 anyway. So we just have to do 0.92 to the 15th power, which in this case gives us about 0.286 or 28.6%. So we can do the same thing for if we're going to shoot 15 and make exactly 10 then. If we make exactly 10, we're talking about 15C10, probability of success to the 10th power, probability of failure to the 5th power then. Now actually, because I usually start at 0, I'd usually put a 5 here. But it doesn't matter. Pascal's triangle is symmetric, so these terms are symmetric out front here. 15C5 is the same as 15C10. So we could evaluate this then. We could do 15C5. Probability is 0.92 that we make it to the 10th power. Probability that we miss it is 0.08 to the 5th power. So we'd have to evaluate that in our calculator. So with our calculator, we can do 15, go to math, let's go over to probability, C5 or C10, and then we're going to then we're going to multiply this by 0.92 to the 10th power, and then times 0.08 to the 5th power. Hit enter. That gives us our probability. And another way to do this actually is go to this right here, second vars, which is distribution. If you go to second distribution and scroll down, you'll see this binomial PDF, binomial probability distribution function. And it kind of just walks you through how many trials are there. There's 15 shots, so 15 trials. Probability of success P is 0.92. X values what term we're looking for with the 10th term, or making 10. And if you enter that, you should get the same thing than we do here. All right, let's practice some homework.